Shoham and I prepared this notebook. This was the part of our assignment given by our industrial training instructor, Sir Bapuji Kanapati sir, and I used this dataset that was provided by him as well. This one, Bengaluru House dataset. So let's start. So the objective of this project was to predict the housing price using simple linear regression and multiple linear regression. And I have performed this regression 2 times before and after cleaning the data so that we can have a great overview how the outliers act, how the outliers affect our final prediction. Okay. So these are the libraries that I have used. There is NumPy, there is Pandas, there is Matplotlib, there is Seaborn, there is regular expression as RE, and some more modules from scikit-learn library, that is train, test, plate, linear regression, level encoder, and these are to just see how my model has performed. So I have imported this dataset. Then I printed the sample rather than the head so that we can have a better overview, like what exactly are you dealing with. I'm sorry, I need to run this cell first. Okay, so as you can see, there are two. Okay, so first we need to print the info, right? So that, just a sec. Yes, then this and this. So yeah. So we have the path column, the balcony column, and the price column, which are of float data type, and the rest of these are object. So we need to deal with this because in the simple regression models, we need to have as many numerical column as possible so that our system or our machine can predict well. So we have this bath column, this balcony column, and this price column. Okay, and the square feet column may look like this numerical, it is actually object. There are certain, as I have seen, there is certain range, there are many other things that is in this column. So, and these are self-explanatory: the area type, the availability, the location, the size of the society. In the area type, there are some classes, right? Some super built-up areas, some plot areas, some built-up areas, like this. In the availability, there are some days, there are some ready to move, and there's some instant join, something like this. In the location, I've seen that the top 50 location consists most of the data. Okay, so we'll be working on that in the data cleaning and preprocessing section. Okay, so let's move on. I want to see how many null values are there. So I use df.isNull.sum, this method. So as you can see, there location, there is one null value. In size, there is 16. The society, there is 5,502. So we'll be dealing with this further. Then I printed the describe method and to see the count. These are not like counts in this. Okay, so the describe method works on mostly on the numerical column. So as before the preprocessing, there are only three. That is bath, balcony, and price. So this count and this describe, this count, standard deviation, mean was only applied over these three columns on. So count is this, mean, standard deviation, mean, and these are like, we shouldn't take this seriously, as there are so many outliers. As you can see, the max values and from the mean values, the range is huge. We need to work on this, then it will be much more significant. Now, moving to the next part, there is data visualization before cleaning. Like, there are some outliers, we'll be dealing with those. Before that, we performed this data visualization thing. So first, using Seaborn library, I did the his plot, and I kept KD as true so that I kept this line. I print the price, and as you can see, the price most price is between 1 and 500, and there are some extremely high counts. We need to deal with this. Okay, so these are not actually following. As you can see, there are plenty of outliers. We need to tackle those. This is what came out of the box plot, and df price, then you have the column is a target variable, and this data is highly skewed and extremely extreme outliers values are present in this data. So we need to remove those. Next I use the subplot method and print this bath, balcony, and total square feet. This is the his plot, which is basically the frequency, the the intent, not the intensity. Like this tells us the frequency of how many, like 1 to 10. Let's say there are two, and how many plots are there. That has the count two. So these are not following a normal distribution, like any other typical data. So does has some outliers. We need to remove those. We'll be doing this in the pre-processing section. And again, I plotted the scatter plot, like the same subplot method. 1, 3 means there are 1 row and 3 column, and the size is 12, 5. I use SNS or scatter plot, so that I have written less code. So this is the 1, this is the axis 2, this is the 0, this is the 1, and this is the 2. On the x-axis there are the independent variable, which is the bath, balcony, and the civil square feet. And on the y-axis I printed the price. So this is the scatter plot. And then I printed the box plot. So bath has the box plot. Like if I do df bath dot min, I'm sorry, this is only one bath is present. But if I do max, you'll see there are plot with 40 bathrooms, which is not realistic. So to work on that. Okay, so now I printed this categorical data, as histogram is only used for, and the box plot is only used for numerical data, and this categorical data like area type, availability, and size. These are the categories. I printed those just to have an overview. Actually, what are we dealing with? So I print the heat map. Only there are 3 by 3, like only numerical values before the cleaning part. So there is bar, there is balcony, and there is price. And the most correlated column with price, with respect to price, is this bath column. So in the SLR, we took X as this bath column. I know this is not good, but this is what is. I just wanted to see how much our data can, how much our output can, actually how much our accuracy can differ from before and after dealing with the outliers. So I created a new data frame. I named that df.copy. And the new depth coffee I filled with all the null values. As we've seen, there are plenty of null values. I substituted with mean as a benchmark. I know this is not the right thing to do, as there are so many outliers, but I still substitute with mean, and I'll be dealing with this later. And similarly, as path, I filled with mean as well. So XSLR is I named the variable. I put the df.new as I've copied into df.copy into df.new, created the entire new data set. So df.new, I put the bath, and the df.new the price, I put the y's. Then I applied the trend test split as I have already imported it from the external library. SLR and test size is 20%, which means the y test there will be 20% of data, and the random state I kept as 42 so that I could reflect my output. So I created the object, named it SLR Simple Linear Regression. Then I use the fit, and I pass X train and Y train. So my object is fit. Then I YPET created an entire new column. So I predict the value of SLR test. I pass this on my SLR model and got this output. Then I printed the mean absolute square, mean error square, and R2 score. As you can see, MA and MSC absolute error and square error are quite high, and R square is quite low, which is not good, because this is supposed to be high and these are supposed to be low. So this is 19 for 0.9. There is my 19%. This means that only 19% of the variable is predicted by our simple linear regression. Okay, this is not, obviously it's not good. So I've written some documentation which will be better for our notebook which I have prepared. This is the one. I'll talk to it later. Okay, so MLR on the raw data. I perform a quick encoding. So this is the categorical data, which is area type, availability, location, site, and society. I create an object of the label encoder, which is a function from this string library. I create an object named it LE. Then I perform this new column is as type of string. What this does is there are some, there are some. This takes these values chronologically. Like in area type, there were. If I do this sample, we are doing sample. If I do head, okay. So new df and to run this. Just a second. This if I do head, so there in area type there were like super build up area and build up area and all. So this there are four. So this encoded is 0, 1, 2, 0, 1, 2, 3 up to this is a 4 column and named it like number of their chronological order. So this is not a good, this is not a good price to it. But I did this as set the benchmark so that we will be performing our outlier, dealing with the outlier later. So and we'll have a better, better data set. So I did this for all these categorical columns, which is area type, availability, location, size, and society. And the total square feet column is totally different. I have dropped it. So as you can see, there are no null values. I substitute this with all, and there it is. I dropped the total square feet. I have written why I've done this. So the basic thing is there are some range values. There are some values with digits and the units in under after these digits. So we'll be dealing with this later. For now, I just drop this. I drop the price also, which is a target variable, and put those in an X MLR and Y MLR. We have the target variable. Okay, so I did the trend speed as like last time, and I get this as a new, you know, as a new error and R square. As you can see, interpretation. This is quietly included multiple numeric features, quickly encoded categorical variables, slowly improve the performance. Like MAE and MSC decreases like it should, but R square increases to 0.24. Like earlier it was 19%, right? So this is better, but not like sufficient. Okay. Now we are doing the data cleaning and pre-processing. This is the most important step. So our objective is the missing values. We have to work with the missing values. Then we need to do some feature engineering like location, area type, size, etc. Now, inconsistent and incoherent data this needed to be taken care of. We'll be doing this, and we'll be dealing with some numerical features, right? Okay, so to handle the missing values, so df.clean. Okay, so just a second. So the df.clean. This I created another data frame named df.clean. Earlier this was ds.new, now ds.clean. And the balcony and the bath column we substitute it with median. This is much more like better. What is median does is median internally arrange all the values in increasing order and then it takes the middle values, which is better, which is not affected by outlier. So I did this, substituted bar null values with median, and the society I did independent because I said earlier, there are plenty of null values in the society, right? Approximately it was 5,000 something. It is 5,502. I substituted all these null values independent, like they are not part of the society, they are individual houses. So this mark is independent. Then after then the next the size. Size column, there are 2 BHK, 4 bedroom, 3 BHK. So here what did was I took the column, then applied string.split method. What this does is this will create a list like 2 BHK. This will split it like there will be two separate items, that one is 2, then one is BHK, and I have noticed that the numerical value which we will be needing is always in the top. So I took the first, that is string in bracket 0th item and 0th index. So I will take the 2 and I typecast it into float. Then I reassigned it into the df.clean size. Okay, so this is what came after I did this, all the floating values, but there, as you can see, there are null. So again, I substitute the null value with median, like I talked earlier. Then I drop the location column. Why? Because I will be dealing with location and I will be using one hot encoding. So I drop the location column is now an index 0. Like I've done this. Now there is no missing values. Now I have to deal with the square feet column. Is the most tough part of this project. So what I did was I first see the how many unique values are there. So there are as you can see there is some range and there are also some string values. So what I did was I create a function clean to a square feet. First, if the value is already float, I just need to return. I used a try and except method. So if the value is already float, I just returned it. And except if the value is not float, what I did was there is a function in the regular expression. What does this is backslash d plus. This means backslash d is for integers and plus means more than one integers. That this backslash d plus is written if there are one and more integers at the start. Then backslash dot question mark. This means if question mark means if there is true that will be happening or otherwise it won't. Like backslash dot question mark means if there is any decimal values that will be passed as well. If there is not, no issue. But this means this have to be returned. Similarly, the star if there is any values it will be returned. That will be all stored in the num. If not num, it will be returned, which means I will be using the mutator. If the average if multiple numbers in the range, that we will be returning those and return the will be mapping the float numbers divided by length. Like if there is a range like this, I will be taking the average. I will be summing this up and I will be dividing the length of this thing, which is this case is 2. I will be returning this average as our what is the current name as one num. Okay, so I use the apply method which applies into the all rows of the particular column. So df underscore clean equals to df underscore clean total square feet. Apply df apply clean underscore total underscore square feet, which is the name of function. And similarly, if there is any null values, we will be replacing with this median. So this all happened. After that, I just wanted to check what is the type of our recent variable. As you can see, all are float, right? So how many numerical columns we have right now? Those are float, those are square feet, path, balcony, and price. Now we have to do also size as well. Like we have done this. Now we need to need to deal with these categorical columns. So what I did was okay, so availability column, this one. So there are some dates, there are some ready to move, and there's some instant join, right? Like list. I created a list, so I did this encoded availability. I will be doing the feature encoding right now. So if X in either this is ready to move and this is immediate join, I will be returning marking as 1. Otherwise, if there is date like maybe the joining is 2 months later or the 3 months later, I'll be marked as 0. That's not exactly. I'm not saying this is the perfect thing to do, but I did this to to make this less complicated. So availability column 0, 1, and all. Like 1 is for ready to move or immediate procession, and 0 is for if there is a date. So I did this df.clean. Like now the availability column is now integer. Like it should be bool, but it will not affect our machine, I think. Next, I'm dealing with the society like this. There are some theta independent. I've already done this. I've just make those certain null values as independent. And when I did the value count, as you can see, other than the independent values, this mostly top 50 societies has most of the plots, right? So what I did was I created a variable named the society count, which I did some value count. Okay, so I took the top 50 head. I took the top 50 head and kept it, and it's to list. Top location equals location dot head counts head index to list. Society count and location count. Okay, so I performed this on two different columns, that is the society as well as the location. So I did these similar things. First, I did the value count, which will usually returning like this. I will be taking the top 50 categories from each column, and we'll be clean those, right? Mm, Top society equals to society counts, which this variable head is top 50 index to list. So what this does is, as you can see, it is. So what this does actually is we'll be keeping those top 50 counts as these all have 80, 76 or 10 values, and we'll put other on the remaining ones, right? So I apply the lambda function here. Lambda x means this will be applied in all the all the rows. X if x in the top society, that is this list, else other. So we'll be keeping as the name, all will be writing others. I've done this on both society and location. So after cleaned society, this looks like this. Other independent, other there's some place name. I have done this. Next, I'm using one hot encoding. So this categorical data, which is area type, availability, location, size, and society, we have performed the one hot encoding. Like we'll be having each value count as row, and we'll be having false and or true. Like if some if some plot is in certain area, will be giving this will be giving us true, otherwise this will be giving us false. So what this does is this increases the column count, but this gives us a general perspective about the data, right? Okay, we did this. Now we'll be dealing with the outliers. Okay, so there are, as our instructor taught, there are two ways of dealing with these outliers. One is IQR, that is interquartile range, or another is Z-score method. So in the interquartile range, what we do is generally we take Q1 equals to 1.2 times of the QR. This mainly does in the box like this. And we will be setting one lower bound and upper bound, and the IQ will be cleaning the quart. We'll be taking the 25% of this, and we'll be applying multiplying it with 1.5, and we'll be removing our boundaries. Like if the range is between 100 and 0, we'll be dealing with just 75 and 15. We'll be removing those, and we'll be removing the rest part, right? We can do this, but another method is the Z-score method. We basically take X, like each value, we subtract it from the mean and divide it with the standard deviation. But the one disadvantage is sensitive to the skew distribution, that we take the mean, right? And as you can see, as we have seen already from our plot, that our data is highly skewed. So we're not going to deal with the Z-score method. We'll be doing it in IQR method. So I applied this for these columns only: size, 12 square feet, bath, balcony, and prices at the or numeric columns, which are mostly as float values. So I've done this. I took this clean data set. I took the quartile of 0.5 and 0.25. I like the 1/4, like the top 25% and the top bottom 25%. I remove this. Then I apply and the boundary like this 1.5 is the standard. standard. Then I create a new data set if like this. If the clean column is lower, is the higher than the lower bound and the lower than the upper bound, then only we'll be keeping the data. Otherwise, we'll be dropping it. Okay. So this is the new data set df clean, and after printing the shape, this only we found is 10,000 something, and nine columns are present. If we print this data, it looks like this. There will be less availability, less outliers. Then we perform this one hot encoding, like we use the get dummies on the categorical data on the df.final. So the data we got. Yeah, this pretty much it. Next we printed the heat map so to see who is the most correlated column among my data. And this looks huge just because we have already performed this one hot encoding. So this heat maps look like this. Now we need to pick the top correlated thing for our simple linear regression correlated column. So core with price, this core matrix is the function we use, and the sort values this is ascending false because this is the default from ascending. We say this is false, we'll be getting a descending value. The price which should be correlated with price 100% one. And the next thing is the total square feet, which is 67%, right? So this total square feet as our x value, then we pass this, we perform the simple linear regression, and the score is much greater. Like it is 17% only error, that is, and our R square is 41%, which means 41% of the data can be explained through our simple regression. If we take x as a total square feet, the variance can be explained 14 up to 41%, which is not good, but it is decent, right? Next, we perform the multiple linear regression. We drop the price. Okay, so we took all the 12 columns. I think we took all the 11 columns. Then we MLR, we pass the price. Then we perform this. Now this is quite good. This is 59% nearly. So this means up to 60% of the variance can be explained if we take and perform multiple regression after dealing with those outliers, after those feature encoding, right? So this is quite good respect to the linear regression on this data set. So yeah, now the conclusion is that after cleaning the data set, handling the missing values, converting total square feet to numeric, removing outliers, and after encoding the features, we applied both linear regression and SLR on the house price prediction, and this is the result. After those the R square is up to 0.6, that is 60 up to 60%. This is really good. Earlier with the outliers, it was like MLR was 24%. So this is a huge jump. And the takeaway is that from this project is that using the multiple 11 features captures more information, right? Like I've already seen earlier, we took only 3 columns with a numeric, and then we later took almost 12 columns. And cleaning, outliers removal, and proper encoding are crucial, which is kind of self-explanatory. And these demonstrate the importance of feature selection and the data pre-processing in the real-world machine learning projects. Yeah, so this was it. I have uploaded this notebook on my GitHub, where it is. Just a second. Just a second, sir. Yeah, I think this. Yeah, I've uploaded this on my GitHub. I'll be attaching the link of my notebook in the description. Yeah, thank you. This was my part.